Welcome back to another deep dive. Today, we are doing something completely different.
Yeah, a bit of a departure for us.
Usually, we take a stack of articles, maybe a new book release or a research paper, and we talk about them.
From the outside looking in.
Exactly. We act as observers, dissecting the information for now. But today, we are going to step inside the source material. We're running a simulation.
It's a bit of a role-play experiment, isn't
Yeah.
it? And I have to say, looking at the documents we have today, I'm genuinely excited about this.
Me too.
This isn't just theory. This is the real world of high-stakes employment. We have two very distinct, very conflicting documents in front of us.
Right.
On one side, we have a job requirement document from a major Tier 1 financial institution. We can't name the client. Let's keep them anonymous.
Yeah.
But I want you to picture the biggest, most traditional, too-big-to-fail bank you can possibly imagine.
Okay, I'm thinking marble floors, ancient vaults, three-piece suits.
Intense regulation.
A whole lot of regulation. This is the bank vault.
Yeah.
It represents stability, history, and let's be honest, a lot of red tape.
Exactly. And they are looking for a senior back-end developer for their loans department. This is a critical role. And then on the other side, we have the candidate profile.
Ah, yes.
The candidate. And this is not your typical corporate climber who spent, 10 years maintaining legacy code in a basement somewhere.
No, and this is where the real friction comes in. This candidate is a hybrid, a chimera, if you will.
That's a good way to put it.
They have the corporate Java roots, about 5 years of solid enterprise experience, but their recent passion, their deep dive for the last few years has been in the Wild West.
Wild West is right.
We're talking blockchain, DeFi, smart contracts, security auditing. This person even submitted a project called Chaincron to Y Combinator.
So the mission for this deep dive is to see if these two worlds can actually collide successfully. Can the crypto architect, someone who is used to decentralized finance, where the motto is often move fast and break things, can they convince the bank vault manager that their experience with rug pulls, hackers, and smart contracts actually makes them better suited for a boring, stable loan system?
It's a total clash of philosophies. Code is law versus...
Regulation is law.
Exactly. So here is how we are going to structure this hour. You are going to play the hiring manager.
Okay.
You represent the loans department. You care about stability, scalability, and risk management. You are deeply skeptical of hype. You've seen tech trends come and go, and you're still running on Java.
And I am. I've seen technologies explode and then just vanish. I need to know my loan ledger isn't going to vanish with them. I represent the institution.
And I'm playing the candidate. I'm the one with the Chaincron project and the deep Solidity experience. My goal is to get hired. But, and this is key for everyone listening, we are going to break character frequently to unpack the strategy of the answer.
Right. We aren't just reading an interview script.
No. We're analyzing the engineering concepts underneath.
We're going to pause the tape, so to speak, and explain the why. So let's set the scene. You're sitting in a conference room, or maybe a high-stakes Zoom call, given the current climate.
Zoom, yeah.
You're wearing a collared shirt, trying to look professional, but I can see a hardware wallet and maybe a weird heavy metal poster on your bookshelf in the background.
Sounds about right.
And I've got your resume in front of me, and I've got a red pen. I'm ready to grill you.
I'm ready. I've got my water. I've got my virtual whiteboard marker. Let's do this.
Okay, simulation start. I'm looking at the paper, adjusting my glasses. So, I've been looking through your resume. You have strong Java experience, sure. But looking at the last few years here, it's all Ethereum, smart contracts, DeFi security, analyzing rug pulls on PancakeSwap. Look, we are a regulated bank. We process mortgages for families. We don't do crypto speculation. So why does analyzing a hack on a decentralized exchange help us build a microservices architecture for loan processing? Honestly, are you going to get bored here within a month and leave for a startup?
That is a fair question. And honestly, I expected it. But here's how I see it. You view DeFi as speculation. I view it as financial services without a safety net.
Okay.
In your world, the banking world, if a database transaction fails, or if there's a bug in the code that transfers funds, what happens? You have a database admin who can roll back the transaction. You have customer support. You have reversibility.
We do. That's a feature, not a bug. It's called safety. It protects the customer.
Exactly. But in the blockchain world, code is law. If I write a smart contract that holds $1 million of liquidity and I make a single off-by-one error in a loop, or I miss one tiny permission check, that money is gone.
Instantly.
Instantly, irreversibly. There is no admin to call. There is no rollback button. So for the past few years, I haven't just been coding. I've been practicing what I call paranoid engineering.
Paranoid engineering.
Yes. I look at every single line of code as a potential million-dollar liability. When I review a loop, I don't just check if it works. I check if someone can manipulate the state to drain the funds. So, to answer your question, I want to bring that level of high-stakes precision to your loan system. You want stability. I've been training in an environment where instability is fatal.
Pause. Cut.
Yeah.
Let's bring character for a second.
Okay.
That was a very specific pivot you just made. Let's unpack that.
It felt like the only way to survive that question. If I just said, oh, I also know Java, don't worry about the crypto stuff, I lose. I look like I'm apologizing for my best experience.
Right. You'd be devaluing yourself.
I had to frame the liability of crypto as a training ground for quality, for precision.
And it works because you touched on the single biggest anxiety of any bank: risk. The source material for the candidate mentions institutional governance and auditability. By contrasting the no safety net nature of DeFi with the bank's absolute need for security, you are basically saying, I treat your money with more fear than you do.
That's the insight, isn't it? In a traditional bank, engineers can almost get lazy.
They can.
Because the infrastructure saves them.
Precisely. In Web 2 development, your traditional app development, we rely heavily on the infrastructure. If the server crashes, the load balancer spins up a new one. If the database locks, we roll back the transaction.
Right.
In Web 3, the infrastructure is hostile. The network is adversarial by design. By highlighting that, you're challenging the interviewer. You're saying, you rely on the database to save you, I rely on the code. That is a powerful hook.
It changes the dynamic.
Completely. It changes it from, can you do this job, to, wow, we need that mindset.
Let's talk about the specific technical skills mentioned in the profile. It lists access control and privilege boundaries. How does that translate from, crypto land to bank land?
Okay, think about it. In a bank, access control is everything. Who can approve a loan?
Right.
Who can disperse funds? Who can change the interest rate? This is RBAC, role-based access control. It's the boring stuff that auditors live and die by.
Yeah, it's usually just a checklist item for a lot of devs.
But in Solidity, the language of Ethereum, if you screw up an access control modifier, like only owner, it's not just that someone sees data they shouldn't. It's that anyone can become the admin and delete the contract or mint a billion tokens.
Stakes are existential.
Exactly. So when you transfer that mindset to a microservices architecture for loans, you're looking at the JWT tokens, the JSON Web Tokens used for identity, with a microscope. You aren't just checking, is this user logged in?
No.
You're checking, does this user have the specific loan approver scope signed by the correct authority? You become obsessed with the boundaries.
So the argument is that the stakes in crypto forced me to be better at the very things the bank cares about most. Access control, governance. I'm not just a coder, I'm a risk officer who writes code.
That's the pitch. You're selling high-stakes precision.
Okay, let's jump back in. You've piqued my interest. You're not just a speculator, you're a security hawk. But now I need to see if you can actually design a system.
Okay.
I'm pointing to the virtual whiteboard behind you. Pick up the marker.
Let's do it. I'm uncapping the marker, taking a breath.
All right, fine. You have the mindset. Now show me the architecture. We need to build the next generation loans processing application. It needs to be modular, testable, and it needs to connect to external credit systems. Walk me through the high-level design. What are the boxes on the whiteboard?
Okay. I'm starting in the center of the board. I'm drawing a large box representing our core domain. We are going to use a microservices architecture built on Java Spring Boot.
Why microservices? Because monoliths are too risky for the scale you're talking about. We need to isolate failures. If the notification service goes down, it shouldn't stop the loan origination service from accepting new applications. We need blast radius containment. It's just like in DeFi. If one pool is hacked, you don't want the whole protocol to drain.
Standard choice. Spring Boot is in the job spec, so you're safe there.
Yeah.
But let's talk data. Loans have complex structures. Interest rates, cosigners, collateral. A mortgage looks very different from a small business bridge loan. How do we store that? Are you just going to make a table with 200 columns?
No, exactly. That's why for the database layer, underneath the microservices, I'm drawing a NoSQL database. The profile mentions Cosmos DB or MongoDB. And here's why. If we use a rigid SQL schema, every time the business launches a new loan product with a new field, say crypto collateral or foreign asset, we have to do a painful schema migration.
Which means downtime.
Downtime or locking tables. A document store like Mongo allows us to have a flexible schema for the loan application data. It's polymorphism for data.
Okay, I can buy that for the application forms, the paperwork. But what about the ledger, the actual money? You aren't suggesting we store the account balances in a NoSQL document that has eventual consistency issues, are you? I can't tell the regulators the money will appear eventually.
Absolutely not. No, that would be malpractice. For the ledger, the actual credits and debits, I'm drawing a separate box right next to it. This is a rigid SQL transactional database, something like PostgreSQL or Oracle. We need strict ACID compliance here.
Define that for me.
Atomicity, consistency, isolation, durability. When money moves, it's either all moved or not moved at all. No halfway states. In fact, I designed the ledger to be immutable, similar to a blockchain structure where you only ever insert rows, never update or delete them to maintain a perfect audit trail.
Good save. Polyglot persistence, using the right database for the right job. Now let's talk about the plumbing. How do these services talk to each other? The job spec mentions create RESTful APIs, gRPC. That's a bit of a mix-up in the terminology in our HR document, but tell me how you interpret that.
I noticed that, and here's how I would design it to get the best of both worlds. I'm drawing arrows between the microservices. For internal communication, say, between the risk engine and the loan processor, I'm using gRPC.
Why gRPC? Why not just REST over HTTP like everyone else?
Because internally, we need speed and we need type safety. gRPC uses protocol buffers, which is a binary format. It's much, much lighter than passing heavy JSON text back and forth. It reduces latency, which matters when you're doing high-volume processing.
And the type safety part.
That's the most important part for me. It enforces a strict contract. If service A expects an integer and service B sends a string, it fails immediately at the code level. It catches bugs before they happen. It's strictly typed communication.
Okay, and for the outside world?
For the external partners, like the credit bureaus or the mobile app, we expose RESTful APIs. It's the standard. It's easy for everyone to integrate with. You don't force a third-party vendor to use your internal binary protocol. So we have a gRPC core for speed and safety and a REST outer layer for accessibility.
Okay, I see the boxes. But this is a distributed system. What happens when things happen out of order, or when we need to do 5 things at once when a loan is approved? I don't want the user waiting for 5 seconds while we send out emails and update ledgers.
Right. That's where I'm drawing a pipe running through the middle of the system. This is Apache Kafka. The job spec lists it as a preferred skill. This is our event backbone. When a loan is approved, the loan service doesn't call the email service and the ledger service and the audit service one by one. That's slow and it's brittle.
So what does it do?
Instead, it publishes a single event, loan approved. Then all those other services listen for that event and do their jobs independently, asynchronously. It decouples the entire system.
All right, pause the simulation. Let's take a breath. That was a textbook modern enterprise architecture answer.
It felt like I was checking boxes from the job spec one by one, but trying to weave them into a coherent story. Microservices, check. Spring Boot, check. Kafka, check.
You were, but you justified them. That's the difference between a junior and a senior engineer. A junior says, I use Kafka because it's cool, or because Netflix uses it. A senior says, I use Kafka to decouple the email service from the loan service so latency doesn't spike and a failure in one doesn't kill the other.
Yeah.
You focused on the why.
Let's dig into that polyglot persistence thing. Using Mongo for forms and SQL for money. Is that really common in banks?
It's becoming the gold standard. We realized about 10 years ago that trying to force everything into rows and columns is it's painful for things like a user profile or a loan application, which change all the time.
Right.
But we also realized that NoSQL is terrible for accounting. You need that ACID guarantee.
Can you just quickly define ACID for the non-coders listening? We hear it a lot.
Sure. Atomicity. The transaction happens all at once or not at all. No partial updates. Consistency. The data is valid according to all rules before and after. Isolation. 2 people doing things at the same time don't mess each other up. And durability. Once it's saved, it stays saved, even if the power goes out. Blockchain is basically the ultimate ACID database, just very, very slow. So knowing when to use which DB shows you understand the data, not just the technology.
And the gRPC versus REST distinction. The source material had that slightly confusing line, create RESTful APIs, gRPC.
Right. HR departments often copy-paste these things. In the real world, gRPC and REST are different protocols. gRPC is like a direct telephone line speaking a compressed, private language. REST is like sending a formal letter written in English.
That's a great analogy.
By clarifying gRPC for internal, REST for external, you showed you understand the trade-offs. You didn't just blindly follow the spec.
There was one more thing in the whiteboard section, the front end. The job spec mentions Angular and TypeScript.
Right, and you, as a back-end dev, need to support them. You can't just throw the data over the wall and say, not my job.
So in the simulation, I would add, for the Angular team, I'd implement a BFF, a back-end for front-end pattern. Or at the very least, we'd generate the TypeScript interfaces directly from our Swagger or Open API specs.
Why is that important?
Because I don't want the front-end devs guessing what the data looks like. If I change a field name in the Java backend, from customer name to client name, the Angular build should break immediately if they aren't compatible. No surprises in production.
That is the answer of a developer who has been burned by front-end integration bugs. It's about seamless integration, as the spec says. It's about empathy for the other team.
Okay, so I've drawn the pretty boxes. The manager seems happy enough with the architecture. But now comes the real grilling, the move carefully part. This is where I think the crypto architect really shines.
Yes. The manager looks at the whiteboard, crosses their arms, and says, pretty diagrams are easy. Production is hard. Let's talk about when things go wrong.
Bring it on.
We have a scenario. It's the end of the month. Everyone is trying to process loans. 2 different administrators on 2 different computers try to approve the exact same loan application at the exact same millisecond. Maybe one is clicking approve and the other is clicking reject or update amount. How do you prevent the system from corrupting the data? How do you handle this concurrency?
This is a classic race condition. And honestly, this reminds me of reentrancy attacks in Solidity.
Explain that connection. I'm listening.
Okay, so in a smart contract, a hacker might try to call a withdraw function repeatedly before the balance is updated, effectively draining the funds. They exploit the time gap between the check and the effect. The solution is the checks effects interactions pattern or using a mutex lock.
And in Java?
In Java and Spring Data. We solve this with optimistic locking. We add a @version annotation to the loan entity in the database.
Walk me through the flow. How does the database know?
Okay. Admin A reads the record. They see it's version 1. Admin B reads the same record. They also see version 1. Now, admin A saves their change first. The database updates the record and increments the version to 2. A few milliseconds later, admin B tries to save. The database sees they're trying to update based on version 1, but the current version is 2. It detects a collision. It throws an optimistic locking failure exception. We catch that exception, and we send a message back to admin B's screen. Sorry, the data has changed. Please refresh and try again.
So you'd rather fail the transaction than allow inconsistent data?
Absolutely, 100%. In a financial system, consistency is always more important than convenience. We can't have a loan that is both approved and rejected. That's a corrupted state. In crypto, a corrupted state means the project dies. In banking, it means the regulators shut you down. It's the same catastrophe, just with different consequences.
Pause. That is a great bridge, a really great bridge. You took a very specific Java JPA concept, optimistic locking, and you explained it using a blockchain analogy reentrancy or a double spend attack.
It just feels more intuitive to me that way. It reinforces the crypto architect persona. It shows that I'm not just memorizing Java interview questions. I understand the fundamental computer science problem of concurrency.
And reentrancy is a scary word in crypto. It's how the famous DAO hack happened in 2016, something like $50 million gone in minutes. By using that word, you subtly remind the manager, I know how to stop hackers, so I can definitely stop 2 bank tellers from clicking a button at the same time.
What's the next grow question?
External dependencies. The job spec mentions integration with external systems. Let's say we need to pull a credit score from Experian or Equifax. We call their API, but their API is down. Or worse, it's extremely slow. It's taking 30 seconds to respond. This is clogging up our server threads. Our entire system is slowing down because the credit bureau is having a bad day. What do you do?
I've dealt with this exact problem with Chainlink oracles. In DeFi, if you rely on an external price feed, like the price of Ethereum, and it stops reporting or it reports garbage data, your entire protocol can collapse. The answer is circuit breakers.
Go on. How does that work in Java?
I would implement Resilience 4J in our Spring Boot application. We wrap the call to the credit bureau in a circuit breaker. Think of it like a fuse in your house. If the external API fails or times out more than, say, 5 times in a minute, the circuit trips and opens. For the next 30 seconds, we don't even try to call the API. We don't waste the resources. We just immediately return a fallback response, maybe credit check pending, to the user. This prevents our threads from being blocked, waiting for a dead service.
So it stops the failure from cascading.
Exactly. It stops a cascading failure. After 30 seconds, the circuit allows one test call through. If it works, the circuit closes and we resume normal operations. If it fails, it stays open.
And what about the data integrity? What if they send us a credit score of -500? Or null? What if their API is working but the data is garbage?
That requires validation layers. Never trust the input, even from a trusted partner. In my ChainCon project, we had to validate all off-chain data before it touched the blockchain. In the bank, we do the same. We define strict schemas. If the data doesn't match the schema, we reject it at the gate. We log the error, alert the dev team, but we do not let the poison data enter our database. Ever.
Good. You're talking about Oracle dependency and manipulation risk from your profile? It applies perfectly here.
It's the same theme, right? Distrust everything. In banking, sometimes we trust our partners a little too much. In crypto, you trust no one. And that zero trust mindset is incredibly valuable here.
One more technical question. This is about the plumbing, the boring stuff.
Okay.
You mentioned CI/CD in your resume, and we have a requirement for maintaining high code quality. How do we know this code is actually safe before it hits production? I don't want to find out about a bug in the live environment from a customer.
This is where I bring in the ChainCron experience again. We built end-to-end observability and pipelines. For this loan system, I'd set up a Jenkins or GitHub Actions pipeline. But it's not just about running unit tests.
What else is there?
We need static application security testing, or SAST. Tools like SonarQube that scan the code for common vulnerabilities automatically with every commit. But I'd go further. In smart contracts, we do formal verification. Mathematically proving code can't enter certain states. For Java, I'd insist on contract approval hygiene in our code reviews. No code gets merged unless it has 2 senior approvals and passes all the integration tests.
And what about the heavy lifting, the end-of-day math?
For the heavy lifting like end-of-day reconciliation of all these loans, we use Spring Batch. It's right there in the job spec. We write batch jobs that run at night, recalculating the ledger to ensure every cent is accounted for. If the batch job finds a single discrepancy, it halts and alerts us. We catch the bug before the bank opens the next morning.
Pause. Okay, pause. You mentioned Spring Batch. That is a very unsexy technology. It's old school, it's not AI, it's not blockchain.
But it was in the job spec. Experience with Spring Boot, Spring Batch.
It's exactly. Dropping Spring Batch proves you read the requirements. It proves you aren't just a Web 3.0 person who only cares about real-time streaming. You understand that banks have end-of-day processing. Banks close. Blockchains don't. Acknowledging that difference gives the manager a lot of comfort.
It does.
It says, I can build the shiny new stuff, but I also respect the boring old stuff that actually runs the bank.
It's that balance again. Kafka for real-time speed, Spring Batch for the nightly cleanup, and absolute accuracy.
Okay, you've survived the technical grilling. The manager is nodding. They see, your Java, your patterns, your security. But now we move to the soft skills, the engineering leader section. This is often where technical geniuses fail the interview.
Right. The job spec says, provide input and decisioning, resolve conflicts, and foster a culture of collaboration.
Right. Banks are political. They're stakeholders, business analysts, product owners. It's not just about code. So here's the scenario. You are the senior dev. A product owner comes to you. They're under pressure to launch a new instant loan feature by Friday.
Of course they are.
They want you to skip the full security audit or bypass the circuit breaker logic we just discussed because it's too complex and might delay the launch. They say, it's just a pilot, it'll be fine. What do you do?
I don't just say no. That makes me a blocker, an obstacle. I need to be a partner. But I cannot and will not compromise on security. So I use the strategy I used in my Y Combinator application. I visualize the risk.
What does that look like?
I sit down with the product owner and I say, I want to launch this just as much as you do, but let me show you the exploit scenario. I walk them through exactly what happens if that circuit breaker is missing. I'd say, if Experian goes down, our entire loan dashboard freezes. Customers will see a spinning wheel. They will call support. The call center will get flooded. It will cost us X dollars in support time and, more importantly, in reputation.
Right.
I make the technical risk a business risk.
And if they still push, if they say, I don't care, my bonus depends on this launch.
Then I offer a compromise, a phased rollout. I'd say, we can't skip the security check, but maybe we can launch to only 1% of users first. Or we can launch internally to employees only. This allows them to hit their launch metric without exposing the bank to catastrophic risk.
I see.
In the blockchain world, this is like a guarded launch or limiting the TVL, the total value locked in, a new contract until it's battle tested. It satisfies their need for speed while satisfying my need for safety.
And what about the team? The junior developers are watching this interaction. If you fold, they learn to fold.
That's the mentorship part. That's critical. I need to show the juniors that it's okay to push back on requirements if it protects the system. I'd treat the code review as a governance layer. I'm not just correcting syntax, I'm teaching them why we don't bypass security. The source profile mentions governance and mentoring engineers. That's my job. To build a culture where everyone feels like they're a risk officer.
Pause. That is the winning answer.
Why? What makes it so strong?
Because you didn't act like a code monkey who just takes orders. And you didn't act like a diva who just says no and insults the product owner. You acted like a partner. You translated technical debt into business risk. You spoke their language, money, and reputation, not just code.
It bridges the gap again. The quote from the profile was, "Delivery-focused teams operating under high regulatory standards."
Exactly. You showed that you can move the ball forward without dropping the shield. You solved the conflict rather than just winning the argument.
So we've gone through the resume, the whiteboard, the technical grilling, and the behavioral conflict. It feels like it's time for the verdict.
The manager closes their notebook. The interview is over. Now, let's step out of the simulation completely. As the expert looking at this, would I hire this candidate?
And as the candidate, do I feel like I landed it?
Okay, my assessment. This candidate is a strong hire. No question.
Really? Even with all the crypto focus, I was worried it would be too risky for them.
Because of the crypto focus. Look, any senior Java developer can build a microservice. That's a commodity skill at this level. But this candidate brings a security-first mindset that is incredibly hard to teach. They don't just build, they defend. The way you framed smart contract safety as the ultimate version of banking compliance was brilliant. It turns a potential red flag, the crypto stuff, into a massive asset, which is risk management. You basically said, I've been fighting in the trenches of the internet, so your bank vault feels like a vacation.
And from the candidate side, I felt like I was able to cover the job specs. I hit Spring Boot, Microservices, Angular REST, Kafka. I didn't ignore the requirements, but I used the weird side projects, chain cron, the Y Combinator thing to show depth.
That's the key takeaway for our listeners. If you're out there interviewing, don't hide your side projects, even if they seem unrelated. Frame them as advanced training. If you build a game, talk about the performance optimization. If you build a crypto bot, talk about the security and reliability.
And the so what for the industry. This isn't just about one interview.
No, it's about the convergence. We are seeing Web3 concepts, immutable ledgers, cryptographic trust, decentralized consensus, starting to bleed into Web2 banking. The fact that the candidate knows Hyperledger-based, which is an enterprise Ethereum client, is a massive wildcard.
That's the twist. The profile mentions Hyperledger-based. We didn't even talk about that in the interview.
Right, but a sharp manager would notice it. Banks are experimenting with private blockchains. Maybe the next generation loan system isn't just microservices. Maybe they want to tokenize the loans. Maybe they want to share a ledger with other banks so they don't have to reconcile every night. This candidate is perfectly positioned for that future while still being able to deliver the Java systems of today.
That is a fascinating thought. The bank vault is slowly becoming a crypto vault, just with more rules and more suits.
Exactly. The wall between the two worlds is getting thinner and thinner. The technologies are merging.
So, to wrap up, whether you are the crypto architect or the bank manager, the language of risk, scale, and trust is universal. If you can speak that language, you can get the job.
And remember, in your next interview, you aren't just answering questions. You are telling a story about how your past challenges prepared you for their future problems.
Visualize your own whiteboard moment. Thanks for listening to this Simulation Deep Dive. We'll catch you on the next one.
Happy coding!